What are we on? 4. Okay, so the first one is 1F. Boo! Didn't we do one just like that? Yesterday. Yeah, Mr. Park, what if the numbers changed? Okay, this problem is on the test. Okay, 100%. Okay, so when you see more than 2 absolute values, you pretty got no choice. You gotta make the number line. What numbers do? Doesn't it look exactly like the one I did yesterday? Oh my gosh. We're in trouble. Okay, now is -3 part of the solution? If I plug in -3, what do you get? You get 3 plus 5 is less than 0. Is that true? I don't think so. If you plug in 0, you get 0 plus 2 is less than 3. I think so. If you plug in 2, you get 2 plus 0 is less than 5. Yes, I think so. I don't know why students have trouble just plugging in whole numbers. Okay, think of a number bigger than 2. That's positive, you leave it alone. 3 minus 2 is positive, you leave it alone. 3 plus 3 is positive, leave them alone. You leave them all alone. And then if you say, isn't that the exact thing that came out from yesterday's one? That's exactly the same thing. It's like not even different. Okay, how do you graph x is less than 5 only over here? You put a 5 on the number line and you go to the left, to the left. Okay, think of a number between 0 and 2. 1. 1 is positive, so you leave it alone. 1 minus 2 is negative, so you negate it. 1 plus 3 is positive, so you leave it alone. So what do we have? What do we have? These cancel out, so you get negative x is less than 1. X is greater than, okay, this one is different from yesterday. I see where the trouble is. How do you graph x is greater than -1 only on this interval? Well, wouldn't it be the whole thing? Because -1 is over here, and you got to go to the right. Think of a number between here and here, like -1. That's negative, so you negate it. That's negative, so you negate it. That's positive, so you leave it alone. So you got -3x is less than 1. X is greater than -1/3. How do you graph that only on this interval here? Well, you put a -1/3 on the number line and you go to the right. And then finally, this last region over here. If you plug in a number smaller than -3, all 3 of them will be negative, so you gotta negate them all. So negate it, negate it, negate it, and then negative x is less than -5, x is greater than 5. How do I graph x is greater than 5 only on that interval? No can, so there's no solution for that one. So whatever's on your number line, that's the answer. So the answer is from -1/3 to 5. It's very mechanical. So like I told you yesterday, on the test on Friday, basically I'm checking these things here. So if you get 3 of those wrong, that's used up all the 6 points already, right? 2 points each. Okay, so like, just mechanically do it, it's easy. Either you leave it alone or you negate it. Okay, next, 2. Did we not? Woo! I would scream out the window, but the outside noise is just going to drown me out. Nobody's going to hear it. Oh my goodness. People, we are in trouble here. Okay, what's the midpoint of this interval? What's halfway between -5 and 2? Take the average. -3/2. How far is it from the middle to the edge? 7/2. So how do you write an absolute value inequality for this? Absolute value of x minus something is less than something. What goes in this one? The midpoint. What goes in that one? The distance from the center to the edge. Can I just leave my answer like that? Don't you dare leave boxes and triangles in your answer. I'm just doing it for your viewing pleasure. Multiply everything by 2. You gotta simplify, right? And there you go. That's your answer. You guys are scaring me, figure 3. Number 3! 3. Didn't we do one just like, oh gosh, you guys are killing me. What did we do last time? I want to cry right now. The 0. Yeah. Oh, I missed it. See what you made me so distraught? I missed it. 1, 3. No, no, and then over here and over here. Now, since some of the dots are filled in and some are not, what does that tell you? Okay, let me just talk to myself. It's going to be a fraction. The ones that are not included, those are the ones that come from the denominator, because the denominator cannot be 0, right? Oh, and x minus 1. Oh, and then x minus 3. Yeah, but Mr. Park, the other one we did only had 2 in the bottom. We still got 3 in the bottom. And then the ones that are included, x plus 1 and then x. Now notice that the ones are shaded in. Now if you make the leading coefficient positive, isn't the one on the far right going to always be plus? So that means all the ones that are shaded in are the plus ones, and all the ones that are not shaded in are the minus ones. And since we want the plus ones, it's got to be greater than or equal to 0. Okay, now you just got to worry about the powers. Okay, so look, if it stays the same, like around 3, 3 came from this factor, you have to have an even power. 1 came from this factor, you have to have an odd power. Why don't we just be fancy, put a 3 then? 0, look, stays the same, we need an even power, so let's put 2012. And then negative 1 changes sign, so this factor got to have an odd power. Let's put 2013 then. And then negative 2 came from this factor, changes, so we need an odd power. 7. There. How's that? But if you just want to use 1s and 2s, you can do that. There's nothing wrong with 1s and 2s. Okay, I'm just going to tell you right now, I think, well, I haven't made a test yet, but that's kind of, I don't think we'll see this on the test. It's kind of too simple. Unless I think of a way to kick it up a notch. What? I don't think I can. Okay, number 4. Okay, why do we have problems with the binomial theorem? We just do, Mr. Park. Okay, see how the power is a negative number? Anytime you have a fraction or a negative number, you got to use the general binomial theorem. I think you're going to be using it at least twice tomorrow. Or Friday. Okay, so what's the first? This is A, this is B, this is N. So what's the first term? A to the N plus N. The power of A goes down by 1. The power of B goes up by 1. Next term, N. N minus 1 over 2 factorial. The power of A goes down by 1. The power of B goes up by 1. Maybe you guys need a song. You guys need a song to help you remember the binomial theorem? Here, look. The power of A goes down by 1, down by 1, down by 1. The power of B goes up by 1. That's the binomial theorem. I just made it up now. Negative n minus 1, n minus 2 over 3 factorial. Some of you just don't. Are you guys seeing the patterns though? If you get 3 numbers on the top, it's 3 factorial. You get 2 numbers on the top, it's 2 factorial. You get 1 number on the top, it's 1 factorial. The power of A goes down by 1, the power of B goes up by 1. How many terms is that? We need 1 more then. So n minus 1, n minus 2, n minus 3, all over 4 factorial. The power of A goes down by 1, the power of B goes up by 1. Anyway, when you guys do these problems, do you guys like notice that the ooh, dum, dum, doo? Do you guys notice that? Dum, 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 doo. Dum, 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 doo. You guys don't notice things like that? No, I'm just copying from the thing. Copying from the notes. Just trying to plug in the number. Okay, now here's the hard part. Simplify. 1 plus 3x squared plus, oh, they're all going to be plus. Okay, what's 6x to the 4th plus 10x to the 6th plus 15x to the 8th. Did I do that correctly? Let's just simplify. So if you want to maximize your points, on the test or on any quiz or test. Write this out first and then start simplifying. Because if you write this down, at least you're showing me that you know the binomial theorem. You're just gonna simplify, right? Okay, now what? Oh, find the 100th term. Oh, so just keep on going until you hit the 100th term. No, there's a pattern. No, there's a pattern. In fact, SAT is coming up soon, right? PSAT. Pattern. So what do you want to do? Do you want to look for a pattern or just keep writing until we get to the 100th term? Okay, look for a pattern. Okay. So the answer is going to be something x to the something, right? Maybe if we put x to the 0 here, you can see the pattern better, yeah? 0, 2, 4, 6, 8. That's a pattern. Come on, this is algebra 2. 0, 2, 4, 6, 8. What kind of sequence is this? SAT prep, we learned this also. This is called an arithmetic sequence because it has a common difference. You keep adding the same number every time. And what's the formula for the arithmetic sequence that you're supposed to know? A1 plus n minus 1d. That's on the SAT cheat sheet. It's in every single Algebra 2 book ever written. You must know this formula when you take the SAT plus. Come on, when you come out of Algebra 2, you're supposed to just know it, right? So what is it? What is A sub 1? I know some of you were in my class. Who's in my class? Ariana Murray? The first term, see? 0 plus n minus 1d. What is d? The common difference. What number do I have to keep adding? 2. This is the formula. You want to distribute the 2? Okay. There. This is the formula that will generate these numbers. See, if you plug in 1, you get the first term. Plug in 2, you get the second term. Plug in 3, you get the third term, and so forth. So if you want the 100th term, what do you think? Plug in 90? No, you plug in 100. If I plug in 100, what do you get? Please help. 198. How many points do I get for that? Well, you might get 1 for now, but this is the main number here. This is the one that, like if this is a problem on the test, you know, I might even ask you to write out I only ask you to write out the first 5 terms so that you can see the pattern. You know? So I might just, on Friday, I just might ask you what's the 100th term, or since I told you 100, not 1,000. No, since I told you 1,000, 10,000. Now, here's the pattern I want you to get. 1, 3, 6, 10, 15. Ooh, what kind of numbers are these? This is from elementary school, people. No, maybe some of you, the first time you learned it, pre-algebra, because I know Mr. Monaco, y'all teach it. This is about tomorrow. These are the the triangular numbers. Because they form triangles. Look, 1, 3, 6, 10. Here, do I have to go on? 10, bowling. Who's on the bowling team right there? That's how bowling pins are set up. 15. And then if I add another 6, you can get 21, right? See how they make a triangle? That's why they call them the triangular numbers. And what's the formula for the triangular number sequence? What's the formula? What? N times n plus 1 all over 2. Okay, well I'm teaching you like you don't know anything. See, because look, if you plug in 1 into this formula, you get the first term. You plug in 2, you get this. You plug in 3, you get that. So if we want the 100th one, what do you think? Plug in 5? No, you plug in 100. If you plug in 100, what do you get? Plug in 100. 100 times 101 all over 2. But 2 goes into 150 times, so that's going to be 5050, yeah? And there's your answer. Okay, I'm going to tell you right now, triangular numbers will occur quite frequently in this class. You have to know them. I know you learned it in pre-algebra, you just don't remember. I can go to Mr. Monaco's room, yeah, we covered that, and we even covered the how come you guys know square numbers then? How come you, let me ask you that. Yeah, that's a question. How come you know the square numbers? 1, what's the next square number? 4, 9, 16. You know how come they call them square numbers? Because they make squares. Now I know in pre-algebra they even do the pentagonal numbers, the hexagonal numbers, the septagonal numbers, and the octagonal numbers, and the nonagonal numbers, and the decagonal numbers. I'm flabbergasted. Okay, next. You guys just don't like the binomial theorem. That's how it seems to me. 4, 5. Yeah, you guys did 5. Hallelujah. And then 6. You guys did 6. Wait a minute. How can you just? Oh, never mind. And then 7. Oh, very good. We got the graphing down. Now remember, the graphing that you're going to get on the test is not going to be straight lines now. It's not. Unless I do put it down. I'm not going to put on straight lines. Or I will. 9 to the 12. Okay, this problem is on the test. This, I don't know what problem. It's either one of the 3 last problems. This is on the test. You have to know how to do this. What are the last 3 digits of this number? Can I use a calculator, Mr. Park? Okay, cool. Use a calculator. I challenge you. Use a calculator. Try punch. Did anybody try punching it in? This number is so big, it gives it to you in scientific notation. How you can read the last 3 digits? Your calculator can't show that many digits. Unless you have a TI-89. Does anybody have a TI-89? Because it can show 200 digits, that's why. But anyway, you're not going to have a calculator on Friday's test. How do you find the last 3 digits? I gave you a hint. You change the 9 to 10 minus 1 to the 23rd. Why? Why? I don't get it. Why? Why don't we try it? What do you think we're going to use here? The binomial theorem. A plus B to the n. Okay, what's the first term? Like in fact, okay, let's save some time here. Do I even care what the first term is? It's going to be 10 to the 23rd power. That's a 1 followed by 23 zeros. Is that going to be useful in figuring out what the last 3 digits are? No, so which terms do you think are going to be helpful in finding the last 3 digits? Yeah, the last terms, not the terms at the beginning, the terms that are at the end. Okay, so let's go backwards. Can you guys go backwards? What's the last term going to be? 23, choose 23. B to the 23. Remember, whatever number is there, that's the power of B. And of course, A is to the 0, so. Okay, what's the next term going to be coming this way? 23, choose 22. A to the 1, B to the 22. Okay, what about the next one? 23, choose 21. A to the 2, B to the 21. The 2 powers always got to add up to 23. Okay, let's just go one more just for funsies, even though you don't need it. 23, choose 20. 10 to the 3rd. Come on, look at the powers of A. Negative 1 to the... Okay, now can you see that you don't need this term? Why not? Because when you multiply something by 10 to the 3rd, isn't that 1,000? When you multiply something by 1,000, aren't the last 3 digits going to be 0, 0, 0? So is that going to be useful in figuring out what the last 3 digits are? Rhymes with mole. No. So we just need these. Okay, I'll do this one then. 23 choose 23 is the same thing as 23 choose 0, which is just 1. And so what's negative 1 to the 23rd? Negative 1. Okay, that one was easy. 23 choose 22 is the same thing as 23 choose 1, which is 23 times 10 times 1. That's 230. 23 choose 21. That's the same thing as 23 choose 2, which is 23 times 22 all over 2 times 1, but 2 goes into that 11 times. So 23 times 11 is 230 plus 23. What did I just say? 230 plus 20. 253! So this is 253 times 10 squared times negative 1. So it's negative 25300. And then whatever this number was over here, we don't know, but it ended in 3 zeros, right? So it's not going to help us any. Okay, so now can you figure out what the last 3 digits are? Look, if you have a number that ends with 3 zeros and you subtract something that ends in a 300, what are the last 3 digits now? 700. And then now I add 230 to it, so isn't it going to be 930? And then you subtract 1, so now it's going to be 929. And so that's your answer. What's up with that? Why am I putting a minus like that? Okay, this problem is on the test. You just got to do it. It's a binomial theorem problem. Okay, so what I want to do is, even though we're not doing Binap's Unique 5, I want to go over the graphing one and then number 6 because these problems are on the test. So if whatever you have trouble at, do those problems. Like probably most of you binomial theorem, right? Do the binomial theorem problem. Okay, so this is Binap's Unique 5. We're doing number 3A. See how you get x squared now? Not to be lines anymore. So do not plot points and try to connect them. I guess you could try, but wasting your time, I think. So how should we do this? What do we do in the other problem? You go by quadrants. Anytime you have an absolute value of an x and an absolute value of y, which you will, you just go by quadrants. I can't believe I'm just telling you everything. So in the first quadrant, x is positive and y is positive. So you leave it alone and you leave it alone. So what do you get? You get y equal x minus x squared minus x. Do I know how to graph that? I hope so. It's just an everyday parabola. How do you graph parabolas? First thing you do is you mactor it. Here, let's just draw a mini graph over here. What are the x-intercepts of this parabola? 0 and 1, and it opens up. How do I know it opens up? Okay. Okay, but we're only graphing it in the first quadrant though. So if I only graph it in the first quadrant, what is it going to look like? What's the only part that lies in the first quadrant? This part. See how it's curved? It's not a straight line. It's curved. It's because it's part of a parabola. Okay, you do that, you get 2 points. If not, you get -2. So if you miss 3 out of the 4, that's -6 already. You lost all your points. Yeah. So over here, maybe we should make it 8 points each. 23 points. You want to do that? Or you'd rather have 6 points and then 43 points? No. Quinto only wants 23 points.
No, wait.
Too late, pounds.
No.
Pounds. Okay. So in the second quadrant, x is negative, but y is positive, so you leave the y alone, but you negate that. So minus negative x is plus x. Do I know how to graph that? Yeah, you factor it. Okay, you want to make a mini graph? The x-intercepts are 0 and -1, and it's opening up. But you only graph it in the second quadrant, so it's going to be like this. Woo! It's starting to take shape. Okay, third quadrant, both x and y are negative, so you got to negate that one and you got to negate that one. So you're going to get negative y equals x squared plus x, which is y equal negative x squared minus x. And then if you want to factor out the negative sign, yeah, why don't we? Okay, how do I graph that parabola? Well, the x-intercepts are 0 and -1. Let's draw a mini graph, 0 and -1. But now it's opening down because the leading coefficient is negative. But we're only graphing it in the third quadrant, so what's the only part that's in the third quadrant? And then finally, fourth quadrant. X is positive, but y is negative. So you negate this one, and you leave that one alone. X squared minus x. So y equal negative x times x minus 1. I'm just going to save time there. The x-intercepts are 0 and 1. Here, mini graph, 0 and 1, and it's opening down. So only the part that's in the fourth quadrant you're graphing, so that's just this part over here. So, and there you go, that's the graph. Yeah.
Do you not graph 0 points?
Oh! You are correct. Very good. That's impressive. Yeah, because zeros, in the first quadrant. Okay, there you go, there's the graph. Okay, so you will have something like this. So what if I change the square to a cube? Just do what you have to do, right? What is that? Look at your neighbor's paper. Oh no, I'm ashamed of you.
What?
Okay, and then let's look at number 6. Find the last 6 digits, okay, because this problem is on the test. Also, Mr. Park, there are plenty binomial theorem problems. Not plenty, out of the 10, 4, I think. Last 6 digits. Are you crazy, Mr. Park? No. 101 to the, okay, now there's no hint. I'm not going to give you a hint. Okay, what do you think we're going to do? What we saw what happened in the last problem. Change it to what? 99 plus 2 to the 13. No, that's dumb. Why do you want to? No. What is it? 102 minus 1. Because the other problem was minus 1. 102 minus 1. No. You may change it to 100 plus 1. Why? Why are we using powers of 10? Because when you raise 10 to big powers, it's just a lot of zeros, that's why. Okay, you want it? Okay, let me just spell it out for you. You're going to use 10 or 100 or 1,000 then. How's that? Just telling you everything. Okay, now we want to know the last 6 digits. So again, do we care about the ones in the front? No, because when you raise 100 to the 13th power, it's so many zeros, it doesn't contribute to the last 6 digits. We have to look at the ones on the end. So what's the last term going to be? 100, choose 100. I can do this in my sleep. You guys got to do this when you're awake. Negative 1 to the... No, it's not negative 1. It's positive 1, fool. It's not. It's plus 1. It's like 1 to the... What? Doesn't it say 13th power? 13. This is 13. 13, choose 13. 1 to the 13th. Oh, so I can just write anything on the board I want. Okay, I'm gonna... 13, choose 9. No, it's 12. A, and then B to the 12th power, right? Because the power of A is 1 there. Then 13, choose 11. 100 to the 2nd power, 1 to the 11th power. 13, choose 10. 100 to the 3rd, 1 to the 10th. Do I need any more? No, because when you raise 100 to the 3rd power, that ends at 6 zeros already, so it's not going to help you figure out what the last 6 digits are, right? So you only have to look at the last 3 terms. Okay, let's compute the easiest one first. What's this one? 1. And they're all plus. It's not like the other one had a minus in there, so you have to think a little bit, yeah? 13 choose 12 is the same thing as 13 choose 1, which is 13 times 100, which is 1300 times 1, so that's 1300. Yeah. Okay, 13 choose 11 is the same thing as 13 choose 2. So 13 times 12 over 2 times 1. So that's 678 then, right? So 78 times 100 squared, that's going to end in 4 zeros then, times 1. So it's 780,000. And then we don't care. So what are the last 6 digits going to be? Just add them, line them up and add, baby. So what do we got? 781301. Can you repeat this on the test? I think you can. But you know, you're probably going to have to do a little more work, so... Anyway. Okay. So we're done here. So what time is this period in? 40, yeah? Well, we got 30 minutes. The other nothing mathematics class is 27 minutes. Perfect. Perfect. Oh, before we start though, there's something funny in the beginning. There's like an owl. There's an owl that's reciting the digits of pi, but he does it wrong. You would think Disney would research that, but apparently not. Maybe they didn't have mathematicians. 3.141592653589793. These are the first 15 decimal places of pi, correct? I don't know, the owl screws up somewhere around there. And they also talk about the golden rectangle. The golden ratio, did we ever talk about that? We talked about it.
No.
Yeah, we didn't have time. Let's just watch the whole video. I'll talk about the golden rectangle another time. Yeah, who brought popcorn? Yeah. Anoka? Muffin. No, last year, every time we said we were gonna watch a movie, some people brought popcorn. But not this year. You guys can lie over here too if you want.